This one is number 13. We're going to do this in both classes. This is a little bit trickier. The question itself asks, it says, the City Commission wants to construct a new street. The City Commission wants to construct a new street that connects Main Street and North Boulevard as shown in the diagram right here. All right, this is Main Street and this is North Boulevard right there. North Boulevard, Main Street, and this is the new street that they want to create to connect the two, as it says, new street. The construction cost has been estimated at $80 per linear foot. Find the estimated cost for the construction of the street. The diagram is key, and what do you notice about this diagram? I added this. On your test sheet it didn't have this, but what does this little symbol tell you?
Right.
It tells you it's a right angle. And what kind of shape do we have in this diagram? What kind of shape is it? A circle?
Angle.
Circle?
Square.
Square? It's a triangle. And what have we been doing with triangles this whole section? What formula have we been using?
A squared plus B squared.
One more time. A squared plus B squared equals C squared. We've talked about it on numerous occasions. It's the Pythagorean Theorem. A squared plus B squared equals C squared. And when we have a right triangle, that's what we go to. It makes it easy. So let's write A squared plus B squared equals C squared. We use that, but we have to label A, B, and C. So what is A, what's B, and what's C? First of all, again, how do you know what C is? Lucas, do you remember? How do we know what C is? Well, how is C related, Sarah, to this symbol? Which side is C? This one, or this one? What, Kevin? Opposite of this right angle, okay? Do you get that, Lucas? It's opposite this. It's this. And in this case, we don't know C. The new street length is not known to us because we're going to construct it. But we do know A and B. What's A and B? Ashley, what's A and what's B? A equals what? A equals 7. Just put A equals 7. What is B equal to? Yes, good. B equals 5. So now we can fill this formula out. Ashley, we're going to put A squared, 7 squared. What's B squared? 5 squared equals C squared. That's 49 plus 25 equals C squared. 49 plus 25 equals C squared. And that's equal to what? 74. C squared equals 74. To solve for C, what do we need to do? This is very important. In a different color now. Get it. Take the what? No, we want to find C. So how do we find it? You have to take the radical of both sides. Okay, that's very important for the next section too. So C equals the square root of 74. All right, put C equals the square root of 74. Now, square root of 74, can that be simplified? Not so easily, right? Because half of 74 is equal to 37. Don't think that too many perfect squares go into 74. But we can use our calculators and figure what that is, okay? So what's the square root of 74? What about the estimated cost? What about the question they're asking? They're asking for what? The estimated cost has been estimated $80 per linear foot, all right? So what is this information telling us?
How many feet?
How many feet? It's root 74 feet. And how do we find the cost? If it's $80 per foot, we have to do what to find the total cost of construction? Multiply. Multiply this $80 times that root 74. For that, we need to know what that is. We need to know what that is as decimals. Does anybody have a calculator?
Why don't you just take the closest perfect square to 74?
We could do that. We could estimate it. We could estimate that. Is this?
It says the estimated.
Oh, that's another point. This is in miles. I think that's a great point that Melissa's found it. This was in miles, and this was 7 miles, and this is in feet. So we've got to convert that. But first of all, let's do this. Let's take the square root of 74 and work that out. What is it?
8.60.
8.60. So just put 8.6 equals 8.6 miles. Equals 8.6 miles. Now we have to convert miles to feet. You won't be asked to do such a thing probably in the final without being given a conversion factor. But anyway, how many feet in a mile? We did that the other day, 5,000 something, right? So let's say approximately 5,300 feet in a mile, okay? 8.6 times 5,300, okay? 8.6 times 5,300. Okay, this is just to get the amount of feet in this right here. Anybody have a calculator for that? 8.6 times 5,300. Anybody? And that's just an approximation. Good stuff. 45,000. Go ahead. 45,000 what? 45,580 feet. Now the cost of this road is, right, the total cost is going to be times $80 because each foot, put $80. Each foot is going to cost $80. So what's that when we calculate that? Tom?
Are you serious?
How much?
3,646,400.
3,646,000. Put dollars there. All right?
But C7, that's pretty far though.
And why not? You know what? That's about right for a road that's going to be 8.6 miles long, right? If you think about it, it's going to be expensive. It's going to be a lot of money. And that's where your tax dollars go, partly. All right? Better be a road worth constructing. It's probably a road that's going to lighten the load for traffic, for instance. There it is. That's a real life problem, folks. Whoever said that math wasn't related to real life? Who said that? You're wrong. You're wrong. This is a real life problem. Real life, man. Real life, man. Real life. Number 15. The square root of 4x minus 5 equals the square root of 3x plus 5. Okay? The square root of 4x minus 5 equals the square root of 3x plus 5. Now the deal with this one is that you have to do what on both sides? This is something you're going to need. This is a technique you're going to need to know. So what are we going to do? Anybody have any idea? How are we going to get to the x? Because we're solving for x. So how are we going to get to the x? What do we got? What's in the way of us getting to solve for x? What's in the way of that? The square root sign, right? So how do we get rid of the square root sign? What's the square root of... Remember this fact. What's the square root of x times the square root of x, Chris?
X.
Good. What's the square root of 4x minus 5 times the square root of 4x minus 5? Well, yeah, you do. Well, let me slow down. What's the square root of 100 times the square root of 100? Right. What's the square root of 4x times the square root of 4x? What's the square root of 4x minus 5 times the square root of 4x minus 5?
Square them both.
Right, right. Do you get what I'm going to here? You see where I'm going with this? The square root of 4x minus 5 times the square root of 4x minus 5 equals 4x minus 5. And that's a good thing because you won't have that sign anymore. So square it. Now, what... Yeah. Kiwana, what's the square root of 3x times the square root of 3x?
3x.
Good. What's the square root of 3x plus 5 times the square root of 3x plus 5? Ian? 3x plus 5. So if you square those, guess what happens? Look at that. Now you can solve for x. Go ahead and solve for x. It's just about collecting like terms then. What do you do on both sides? It's solving for x, Lucas. What are we doing on both sides, Trey? We get the x's on one side and the numbers on the other. So how do we do that? Take away 3x. Let's do it, Amanda. Minus 3x on both sides. If we subtract 3x on both sides, you're going to be pulling that 3x over. And you're going to end up with, there you go, x minus 5 equals 5. To finish this off, what do we have to do?
Add 5.
Move side.
Add 5.
Add 5. There you go. And x equals 10. We're done. So the only real trick to this question was recognizing that the square root of a number times itself is equal to just that number. You're able to eliminate the square root signs by squaring it. That's the inverse operation. If you want to think of it this way, square rooting a number, what does it do to 81? Let's take the square root of 81. Does it make it bigger or smaller? It makes it smaller. The square root of 81 equals 9, and 9 is a lot smaller than 81, right? The square root of 81 is a lot smaller than 81 itself. So what do you do to 9 to make it bigger again? By itself. Exactly. So squaring it and taking the square root are inverse operations, all right? So that's how this kind of works, basically. You've got square root of 4x minus 5, you know you're going to make that smaller, but by squaring it, you neutralize the effect of the square root symbol. By neutralizing the effect of the square root symbol, you get back down to basics and you deal with just the problem that you already know, a linear equation that you can solve by collecting like terms on both sides of the equation and solving for x. All right? So for homework, if you want to get this pretest in and get graded for it in a good way, you need to, on a separate sheet of paper, write down all the corrections, including the questions themselves, and hand that in with the original pretest. So let's say you got 5 out of 15 on the pretest. No sweat, no worries. Go to YouTube or watch in class, write the notes down, write the question out in full, as well as all the work. Box your answer on a separate sheet of paper, hand both the separate sheet of paper in and the original test in on Friday. Bingo, you got your grades, you'll be doing fine. All right? Good luck with that.